amazing presentation that Stephanie Breckwicker will give us on AM on Track, how 3D printing improves the quality of life. Before jumping to Stephanie, I would like to say a few words about her. Stephanie Breckwicker is a managing director. As a managing director, Stephanie set up Mobility Goes Additive, the international leading network for industrial AM in 2016, with the aim of pushing 3D printing into series production. Now, MGA has two divisions, mobility and medical, and more than 140 members. After graduating as an economist from Technical University of Hanover, Stephanie started her career in the mobility sector and has since held various management and project management positions at the Deutsche Bahn since 2015. She has the corporate project 3D printing at the Deutsche Bahn. In addition to her work at MGA and DB, Stephanie is the initiator of the Women in AM network and actively promote women in AM industry. And that's how we also TIPE promote women in 3D printing. Stephanie, welcome to our stage. The floor is yours. Thank you for making time for this presentation.
Thank you so much, Malika. I'm really looking forward to this very, very special event, and yeah, I'm really happy to be with you. So what you can see already on this picture is where I'm coming from. I'm coming from the railway sector, and within the railway sector we've discovered additive manufacturing nearly 6 years ago. And I would like to tell you a bit about what we've done in the meantime. Okay. So if you take a closer look about additive manufacturing in general, many of those technologies come from Europe, many even come from Germany. And Germany and also Europe is quite strong in those branches and sectors where we have a very high level of regulation. So in the defense sector, aviation, of course, where they save a lot of weight. In the shipping industry, to create homecomers, which means spare parts to bring those ships home wherever they might be at the moment. We also talk a bit about the medical sector as well as the automotives, and of course a lot about rail. Now, talking about the automotive sector, they are really struggling at the moment with a lot of strategies they are focusing on. So additive manufacturing plays a minor role at the moment. What they do is they discover a lot of tooling aspects, but not the spare parts in a huge number of parts at the moment. So this is why I would like to come to the railway industry, where we tried 6 years ago to focus on parts which we can't get anymore at the markets. So what we are looking for are quite big parts, since the rail usually is looking for very big parts, and we also need an equivalent for forged parts. What is common to all those parts is that we need a lot of certification, since we are talking about trains where hundreds of people are traveling with. Yeah, so what are the main technologies we are using in the railway sector? A lot of FDM. This is due to the fact that our high levels of quality of flame retardancy are just and only covered by FDM materials. We use powder bed fusion quite a lot, and later on I will show you some parts what it's used for. So for instance, in the polymer sector as well as in the metals. We also tried out multi-jet fusion, since there we can cover a lot of different parts, and also the coloring aspect is very interesting. And we need big metal parts, and therefore we use wire arc additive manufacturing, which you can see in the lower right. So this is a typical part we've printed for the rail sector. It also is responsible for the air conditioning system. This is a driver stand you can see here. And this is a very typical part. And what is really interesting is that it is quite common, like the aviation parts from Lufthansa or other flying companies, but their design is just a little bit different. And therefore, we need this very high level of flame retardancy. You might ask why it is so important, and we have a lot of materials which are already certified for the aviation sector. Yes, but that may be not sufficient. Because in the aviation industry, as soon as you've landed a plane, then you have like 90 seconds until the latest the plane is emptied. In a train, you might need 12 minutes or 15 minutes coming out of a tunnel, being able to stop anywhere, getting all those people out of the train. And if you take into account that what it might mean to toxicity, and also we don't have any oxygen masks in trains, so you will understand that we have a different level of flame retardancy. And that can just be covered with FDM technology. In the railway sector, we have also very interesting cases which are very much individualized. So handrail signs for blind people is a very interesting case because those are very individual. They say this is the street exit XYZ. So those signs are very individual. And you always need the translation into Braille scripture. And therefore, we tried out additive manufacturing of metal parts. And this even lowers the costs up to 50%. So this is really, really interesting. As I already mentioned, railway industry needs a lot of very big parts, and those big parts might also be something like this. So this is a box, a 27 kilogram heavy stainless steel box, which we have on high-speed trains going 350 kilometers per hour. And of course, that is a safety relevant part because it prevents the train from getting too much into the curves. Therefore, we need a lot of certification. And if you do something like that, you really have to cover a lot of certification processes. So this is what we've done. We put it on a test stand and simulated another 30 years of operation, but we just need another 7 or 8. So we did a lot of testings, we did a lot of CT analysis, and now we're absolutely sure that this part is exactly as good as the former part. Because as soon as we try to exchange an obsolete spare parts, then we have to fulfill that form, fit, and function is the same as before. Yeah, and if you go to the printing industry, of course, every printing provider will tell you I can do everything, which is nonsense. So this is why we initiated an audit in cooperation with the certification body TÜV Süd. And we asked our printing service bureaus to do this audit before they deliver parts to the railway companies. This is a general audit logic, which can also be used by other sectors as well. Yeah, so something which came up the year before, so 2021, is the tooling aspect. So usually in other sectors, you will find it the other way around. Usually they pick the low-hanging fruits with tooling, and afterwards they do spare parts. We did it the other way around, but now we also started doing spare parts. And what you can see are little fixtures and templates with can be used to fix little stickers, like here on the headrests of seats. And so before they always had to measure how to fix that little sticker, and now they just have a very easily printed help to do this quite easy and fast. Fast, lean management are also big issues in the rail industry. So this is how we support lean projects in the rail industry with printing little fixtures for such shadow boards. If you might ask, what do you use additive manufacturing in general for in the railway industry? So for us, it's a great solution to get our hands on printed parts from parts we couldn't get at the markets anymore, clearing obsolescence. We also already integrated functions to make maintenance much easier. We even picked some very interesting economic cases. You don't have any minimum order quantities, and especially in the railway sector, we are often talking just about 1 to 50, 1 to 500 parts which are needed. So additive manufacturing comes in and makes sense. We print in our premises and maintenance workshops a lot of tools in the meantime, and we ensure part availability. So what are the latest trends in rail? So what we're needing is an equivalent for rubber parts. So we figured out that silicon printing would be very attractive to us. So this is a technology we are just about to test. Another thing, printing of concrete. And if you dive a bit deeper into printing of concrete, you will find out that there at the point the printing of spare parts was approximately 5 years ago. So they have a bit of a way, but it's already very interesting. Yeah, what kind of rubber parts am I talking about? I'm talking about seals, bellows for dust covers, bumpers, and some elastic holders. So there's a huge variety. And they all have in common that after 6 years, no matter you use them or they are still in your warehouse, you have to throw them away. Because then our regulations say that you are not obliged to bring them into the trains anymore. So this is why it really makes sense to print those parts in small numbers on demand. And with that case, we can save millions of euros. In the meantime, at Deutsche Bahn, the German railway company, which is a huge corporate, there we have more than 300,000 employees, to give you an idea. We started 2015 with the first printed parts, which was a coat hanger. Then we founded 2 years later Mobility Goes Additive. And that was the idea, to get into an exchange with other companies about printable parts and their experiences with certain materials and so on, and to enhance the number of printable parts. 2018, we've printed the first huge metal parts. And then we established something we call an employee competition to get our hands on the great ideas of our employees. Our next big aim, and this is really a huge task, we would like to be capable of printing 10% of our parts on stock. And to give you an idea, just in the rolling stock segment, and we also have a lot of infrastructure too. In the rolling stock segment, we have parts worth 600 million euros on stock every year. As soon as we can exchange that against printed parts on demand by maybe 10%, we have a pure cash out. And this is what we are aiming for next. In the meantime, we've printed more than 25,000 parts and brought them already into the trains. And there we are talking mainly about spare parts. So in our employee competition, and that addresses not only engineers, but also all those people throughout the company, we have 5 categories. We got more than 130 ideas. We had 7 finalists and 1 champion, of course. And here you get to learn what were the ideas. So we have the category in New Shine, and there we had a snap lock for folding tables. We have an optimized rim protection for wire string in the cockpit, and that broke before, and just with a very little part, we prevented that. On and along the track is the next category, talking about infrastructure use cases. And there we designed a simulation model for railway construction projects. And those are very, very expensive, talking about billions of euros. And if you can talk about who's doing what in advance using such a printed model, then the printed model is much cheaper already than the previous model. And you can save a lot of money because everyone has a different understanding due to the model. So, of course, if you want to get your hands on the great ideas, you need also to honor your idea people. And this is what we did in a huge conference. And one of our board members, Sigrid Nikutta, she's here in red dress, also a woman, by the way. She did this in a very, very nice way. And those people, and we're talking about maintenance workers, were really happy to be in such a great event. We brought together all our experiences in the network, not only from the railway companies, but beyond, in a book which is about AM change management. So if you want to introduce additive manufacturing in your company or corporate, then you always have to bear in mind it's a change management project. What's the next big topic? Sustainability. And for the sustainability aspect, we have to talk about circular economy. And there we already have a lot of very interesting answers from the 3D printing industry. Some I've mentioned before. And now we've done a calculation for the metal spare part. In this case, it's a cargo hinge. It is about that big. And there we analyzed, first we optimized the design, and then we printed it and we compared it to the casted, milled, and of course with the printed subject and spare part. So from the original to the AM specially designed part, we've done a lot of analysis. And what's the good news is you save a lot of weight, which is not the crucial in rail. But you also save a lot of material, which is much more interesting. And of course, you save also a lot of energy, especially compared to the milled part, and therefore also with concerning the CO2 emissions. So therefore, we have for the first time real numbers where we compare different production technologies, and now we know that additive manufacturing is the sustainable technology to choose. For instance, this is one of the working groups in our network. We have a lot more in the mobility and also medical sector. And if you should be interested, don't hesitate to contact me. Everyone is talking about becoming more independent from supply chains, also if you want to print vaccines. And this is a new production machine. It's a very huge one at the moment, but in fact, it's a 3D printer for mRNA vaccines. And yeah, so 3D printing already does a lot good in medical, as well as in the pharmaceutic sector, where you will in the future find a lot of printed pills. That is also a COVID answer. That's a 3D printed plaster, which you can dip into a vaccination liquid, and then you can just push it into your finger. It does not hurt as a needle. So maybe for some people who are still a bit skeptical about vaccinations, that might be a great solution. Yeah, so in the network, we have founded with 9 founding members. We have a lot of users of printing service bureaus, of institutes and universities, of machining producers, consultancies, software companies, as well as material providers, with at all 140 members. And if you want to take a look at our website, WeBoost.am, you will find many, many more very inspiring use cases and materials and what they are suitable for. So this will be like a 3D printing wiki in the future. And if you should be interested to bring in your cases, please contact us. And yeah, so Germany is a very interesting market to additive manufacturing. If you're looking for a place to be, to meet, for a co-working space in the special additive manufacturing setting, I would like to invite you to our industrial additive manufacturing hub located in Berlin, and very close to the center. And yeah, so since we're now in a Women in 3D Printing event, and I'm really, really happy that this great organizing team set this huge conference up, we are doing something similar, a bit smaller, which is called Women in AM. It's also a conference now being held for the 5th time this year, and where also just women enter the stage and talk about great use cases and use the pauses to get into a networking. Yeah, if you're coming from the sector which is interested in aero and space, I would like to invite you also to one of our next meetings. And yeah, if this should be so interesting to you that you would like to become a member of MGA like these brilliant and beautiful people, don't hesitate to call me. Thank you so much for your attention.
Okay. Thank you, Stephanie, for this wonderful presentation throughout application from tooling, spare part, and so on, until various processes. It was really insightful. We appreciate that. And congratulations for the Women in AM. I encourage you, to get in touch with the community of women in 3D printing in Europe and in Germany. I believe you guys can host very good events together. I would like to ask a few questions that have been upvoted here in our Q&A. Stephanie, how do you select parts or spare parts to additively manufacture? And what are your guiding factors?
Yeah, so this is a very important question. So when we started with our corporate project, we tried to do this top down. So to get an analysis throughout our SAP systems, and we totally failed, because usually you will not find this information in your systems, whether a part is printable or not. Sometimes we don't even know about the material, because we are not a producing company, we are just a maintainer. And therefore, we put it upside down and said, then we have to create a bottom-up process. So we went to our maintenance workshops and asked our colleagues, yeah, so they indicated what are the critical parts. And then we looked for specific solutions. And this is how we do it very successfully. But this year, we again want to do the top-down process and focus on that again. But it's not really easy. Therefore, you need a very broad knowledge and experience about the printable materials and also the suitable technologies, which we in the meantime build up. And yeah, so, but usually you have to talk to people and you cannot do enough communication. This is our experience. So we did a lot of communication throughout the company. But when we put in the external press, then once in a sudden, many people woke up. And this is also a very interesting experience we had.
Okay, that's wonderful. We still have time for questions. Stephanie, do you have in-house AM capabilities or you outsource? If so, can you mention few partners?
Yeah, until the last year, we 200% outsourced everything. So some of the partners are, for instance, Blue Production and Protique and Fit and some others. And Siemens, of course. So our former suppliers in the rail industry also started already, at least the huge corporates, with additive manufacturing, and Siemens is really a great and big player. And so in the meantime, which means last year, we set up the first machines within the corporate. So we already knew that we want to have a big machine, like for instance, a big wrap. We set up in one maintenance site in the south of Germany. In the north of Germany, we established polymer machines to print spare parts and not just tooling, which we do on the big wrap. We try to establish printing centers in different parts of the country, but with a very specific focus, because we learned that you need very intrinsic motivated people, and you need a lot of knowledge to cope with the machines, the materials, the designs, and anything else.
Great. Stephanie, I saw in your presentation you mentioned one of the largest parts. What process you use there and who is your partner?
Yeah, so for the metal parts, we use wire arc additive manufacturing, and our partner there is machine-wise Gefertec. And printing-wise, it's Rolf Lenk, also a printing service bureau. Coming to the polymer sector, where we use big parts, it's on the one hand Siemens, on the other hand, machine I've already mentioned, and printing service bureaus for the parts was, for instance, also, I guess, Fit.
Wonderful. We had very busy Q&A here. So we have a question that says, through your role, how are you helping other companies learning from Deutsche Bahn experience to expand AM application? If so, any relationships in Africa?
Yes, we have already some relationships in Africa, but I would love to grow that, because I think that Africa is really, first of all, it's a huge market. Then there's a lot of need, and I think this would be a great cooperation. So I'm very, very open to that. What we do within the network is that we share a lot of experiences. And now we have really a lot of members, and just a couple of weeks ago, one member addressed us and said, could you please find out what's going on in the copper printing field? And then we shouted it into the network, and just within a couple of days, we had a pitch event of 18 companies pitching materials, technologies, use cases, and so we got an overall overview. And this is typical for the network. We also try to solve standardization subjects together. We do in the network anything one company cannot solve on its own, like, for instance, also education, ecological sustainability. Talking about a lot about materials. So there we have a very successful materials working group, also led by a woman, Tina Schlingmann. She's also in the conference. And this is what we're trying to solve there.
Okay, that's great. We are done with our question, but I would like to share with you some of the comments from our fire chat here. We have Martina Gildia say, absolutely brilliant presentation. Thank you. Matt Griffith said, thank you so much for sharing today. And Also, we have Mufaro thanking you for the enlightening presentation, and Matt Griffin says, so inspiring, all of your work and contribution to moving industry and culture forward, Stephanie. So, and you mentioned, you know, about sharing is caring, and in this case, caring for AM to grow further. Thank you, Stephanie, again, for being a great presenter and sharing this wonderful presenter. We really enjoyed it, and you can see through the question and the chat. Thank you again. We appreciate your presence at the TIPE and the industry tech. Wonderful. Please feel free to chat with the participant and network as well with them further.
Thank you so much.